G'day team, and again we are back with more vector content. So last video I introduced the idea of parallel vectors and how if two non-zero vectors are parallel, then one vector is the scalar multiple of the other. So now we're going to sort of develop that idea into parallel unit vectors. So we did a little bit of work with unit vectors a few videos ago, so hopefully just a bit of a reminder if you can't remember, a unit vector has magnitude 1, all right? Let's keep that fact in the back of our mind. So we have a non-zero vector v, all right? We're going to use this vector v quite a bit in this first little bit, and it has a magnitude mod v, all right? And that's a scalar quantity, all right? Now, if we multiply this scalar, so I'm actually going to put mod v 1 over mod v, all right, and vector v itself, then we actually get the parallel vector 1 divided by vector v, mod vector v times by vector v. Lots of v's here. So hopefully you remember from the last video that any vector multiplied by a scalar will be parallel, okay? So we've now got a scalar multiple of our original vector, all right? So we're actually going to take the magnitude of this parallel vector, okay? So over here, we've taken the modulus of both terms, all right? So the modulus of this 1 over the magnitude of v multiplied by now the magnitude of v, all right? What we can do, we can split up this magnitude, so these moduli on the fraction. So we've got mod 1 divided by the magnitude of v times by the magnitude of v, all right? Multiplying our fractions, we multiply numerator to numerator, denominator to denominator, and just remember modulus of 1 is in fact 1. So that then brings us to this result here, all right? Modulus v divided by modulus v, so the magnitude of v divided by the magnitude of v is equal to 1. So as 1 divided by the magnitude of v multiplied by vector v has a magnitude of 1, we actually have a unit vector in the direction of vector v, and it will be parallel, okay? So there's a little bit going on there, so just maybe pause, go back, have a bit of another run through of that little proof, all right? As 1 divided by the magnitude of vector v times by vector v, because it has a magnitude of 1, we now have a unit vector in the same direction of vector v because they're parallel, okay? And it's a positive parallel at this stage. So just a couple of cool little results. So a unit vector in the direction of vector v is our 1 over the magnitude of vector v times by vector v. A vector b of length k in the same direction as vector a is k times by, or k divided by the length of vector a multiplied by vector a. So have a look at the sort of the similarities between these two equations here, all right? Remember, unit means length of 1. We're told that vector b has a length of k, so we're just multiplying this whole thing by k. Now, a vector b of length k that's just parallel, not in the same direction, it's just parallel to vector a, could be, all right, not is, could be vector b plus or minus k over the magnitude of vector a times by vector a, okay? So this one here is in the same direction. This one there could be parallel, okay? Two very distinct, different results. So I just want to go through an example with you guys, all right? So if vector v is equal to minus 2 times by I, remember our horizontal unit vector, plus 3j, which is our vertical unit vector, find a unit vector in the direction of vector v. Part B, a vector of length 6 units in the direction of vector v. And C, vectors of length 6 units which are parallel to vector v. All right, let's hit number 1 first. So part A, let's find the modulus of v. Remember, we need 1 over the modulus of v times by v. So modulus v is equal to the square root of the horizontal component, so -2 all squared, plus the vertical component, which is 3 squared as well. Now we get 4 plus 9, which is 13. So we've got the square root of 13 units. Therefore, the unit vector is 1 over this modulus, so 1 over root 13, multiplied by the original vector v. And then we're just going to expand that out, okay? So -2 over root 13i plus 3 over root 13j. And that is our unit vector in the direction of vector v, all right? Now, a vector, so part B, a vector of length 6 in the same direction is 6 multiplied by that unit vector, okay? So 6 out the front multiplied by our unit vector. 6 times by -2 is -12. 6 times by 3 is 18. And then we have our result, -12 on root 13i plus 18 on root 13j, all right? That is all there is to it. Then finally, part C, the vectors of length 6 units and are parallel to vector v are plus or minus, okay? So this is the one we found in part B. So this is the positive one, and then the minus, so both of the signs flip. That is all there is to it, all right? Hopefully this helps you a little bit throughout the questions, all right? We are now looking at chapter 3. I reckon I'm going to say G, all right? So please start working through, 3G.1, questions 1 through 7, all right? I'll leave that there for you guys. I will see you guys in the next video. Catch ya.